Hey, hey, we are on. Oh, come on. Here we go. All right, who's on? I have no idea who's on. Okay, anyone on? What? Okay. Need people to chime in on chat. I think there's like always like a 1 minute or 30-second delay at the very least between when it's real and then when people hop on. So I do need my browser today. Anyone on? Need people on. Sometimes this new Mac operating system is, it's not fun. Anyone? Chime in. Oh, double check. Hello. Hey, GMR. Okay. So, you know the drill. How do we sound? Video, audio. Video, audio. Mic check. Check. 1, 2. Are we good? Are we good? We got GMario. Okay, good. All right. Hello, everyone. It's October. And that means October is National Cybersecurity Awareness Month. It's also Breast Cancer Awareness Month as well. I'm Ming Chow, teaching professor at Tufts. Just welcome to Introduction to Security. Hello, Orieland. Yeah, was that Orieland? Yes. Hello, welcome. And today, we're going to do password cracking. Yeah, passwords and password crackings today. Yep, so part 1 today, I'm going to show you how not to store credentials if you're building systems. If you're building a web application or you're building a system, I'm going to show you how not to do it. Then we're going to gradually work our way up and do it the right way. So, I need some volunteers. Who's on right now? Okay, who's on right now? So let's start off. I'm going to give you a little demonstration on the wrong way of doing things. So who do we have? Orielon. Your password I'm going to give you is, I'm just going to make an account for you. Oops, fictitious example. Who else is on? Okay, we got, there you go. Gonna make a fictitious database table. Give you a password of we got that. Why is it adding an extra period at the end? Why? Why is it doing that? Okay, who else do we have? I don't like this period thing. I don't know why it does that for me. Give you a password of, and then one more we'll add. One more. Why is it stupid Mac OS? Okay. Anyone else? Anyone else do we have here? Oh, how about this one? Do that. Alright, here we go. Here we go. So, the scenario is this. Imagine you're an attacker. You are an attacker, you broke into a system, you steal data. And you steal this database table of users, just like it is. Here you go. This is the information that we have. This is exactly the information that you're stealing, that you have stolen from a system. You break in, this is what you steal. Here it is, and you get a database table of users. You get usernames and password. Here's your table. What's wrong with this? So immediately the attacker is like living in dreamland right now. Yeah, the attacker is living in dreamland. What's wrong with this? If you're a defender or you're a developer and you do this, tell me what's wrong. Tell me a couple things that are wrong. What are the two things? One should come right off the bat. An attacker steal all this user data of username and passwords on a system as is. JL Spivak, it's unencrypted. Yeah, there you go. Nick Rings. Nick Rings is on. Why not? We'll add you in there as well, Nick. Yeah. I think it's Jake. JL Spivak and Nick Rings. It's unencrypted. That's number one. Like flat out, first of all, this is unencrypted. But does anyone also notice something also as well too? It should be very glaring. Does anyone notice something about any of the accounts here? Yes, well, first of all, the biggest problem, the biggest red flag, 5-alarm fire, this is all plain text right now. This is just no bueno. Unfortunately, there are systems out there that just store passwords unencrypted, straight plain text. Yeah, Tufts House says 2 of the passwords are the same. So you will have 2 accounts that are the same. Keep that in mind. So I'm going to call this dump.txt. I'm going to save this to the desktop because we're going to be working with this for the next few months for today. So yeah, Tufts House said 2 of the passwords are the same. So if you take a look at these, the usernames, so you take a look at this record, you have Aurelion and JL Spivak, a different username, but they both share the same password. Okay, this is not good. But the biggest red flag of them all is that the passwords are unencrypted. Okay, now, can we do better? The answer is yes. We can do better than just storing the passwords as plain text. Usernames you would usually keep in plain text for various reasons, including like check, for like error checking, conditional checking. So you want to have username, that's fine. You can use username as plain text. But the problem is the password. You never store password as plain text on a system. And unfortunately, there are systems that do that. We can do a little bit better. Instead of storing the plain text, okay, instead of storing a plain text of the password, we store what is called a cryptographic hash of the password. So cryptographic hash function. What it is, okay, what a cryptographic hash function is this. It's a function that takes in some input. It'll give you some output that is better known as a hash value, aka hash value, aka key. Okay? Now for those of you who have taken data structures and you've actually ever done a hash table before, Hash tables are used for searching, really fast searching, order of one searching. But let's recall, what are the important properties of a cryptographic hash function? Properties. What are the properties of a cryptographic, of a hash function for hash table? Does anyone remember? Anyone remember? What are the important properties of a hash function for hash tables? Okay, deterministic. So that means if Nick Rings and I are using the same hash function and we're putting in the same input, it's going to give us the same output each and every time. No random BS. That's number one. The second one is this. Is what? Anyone know? Deterministic is huge. No collision. No collision. Two different inputs cannot have the same output. Because if there are collision, then well, that's not good. That's not good at all. Okay? And that is extremely important because cryptographic hash functions follow the same properties as, hash function for hash tables, but cryptographic hash functions are used for things like data integrity and for data integrity, and digital signatures. So no collisions is huge. Anyone else? Anyone? No collision. There's yeah, uniform distribution. Uniform distribution, and that is it's going to be really hard to predict. The values are all spread out, so it's going to be hard to predict or guess. And last but not least, one way. Cannot be reversed. Given a key value, you can't go backwards and get the original input. So cryptographic hash functions are one way, or they're also known as one-way hash functions. They're one-way hash functions, can't be reversed. There's no encrypt or decrypt. So wait a minute, what are some of the cryptographic hash functions that are out there? I like the online MD5 calculator at md5calc.com. I like this a lot. And this is a website that has a lot of all the important cryptographic hash functions. MD2 is really old, MD4 is really old, MD5 is really old, but still used today, especially for legacy Linux systems. Yeah, a lot of systems still use MD5. Lots of systems still use SHA-1. For the longest time, Git used SHA-1 for their commit IDs. There's SHA-5256, SHA-512. I'll give you an example. So let's do you can choose your algorithm that you want. We're going to use MD5 for good reason to start off, but you'll see why. So if you do an MD5 of, let's say, well, let's do these real ones. Let's get to it right away. Let's do the MD5 of good 1, 2, 3. The MD5 of the input good 1, 2, 3, the string to encode, gives you this value. So instead of storing the plain text of the password, we store the cryptographic hash, in this case the MD5 hash value of good 1, 2, 3. Okay? What about House of Blues? Okay? And get this value. For Kevin's password, money is the most important thing in the world. Long string. Get that as a value. Good 1, 2, 3. Didn't we do that already? Flower Pots 1931, Giamiro's password. Norman Ramsey's password. And Nick Rings, his life is about people. Does this mean if someone knows your hash function okay, stop. We'll come back to that in a few moments. Does this mean if someone knows your hash function, they can crack your password? Hold up. Hold up. We'll get to that next. All right. So here we go. All right. So now I think we did an improved version. So now, this is what we get. Instead of storing the plain text of the password, we store the cryptographic hash. In this case, MD5 hash of the password. So, with your own human eyes, are we storing plain text data now? No. So on surface, this is pretty nice, right? Yeah, this is pretty nice. It's pretty nice that I don't see plain text data anymore. Okay, but what's wrong? There's two things that are wrong. One of them is very obvious. So this is a step up from storing plain text passwords. So this is still not great for a couple of reasons. Oh, first of all, are there any collisions? Are there any collisions? Well, for two different values, we didn't get the same input, so at least there's no collisions, like, cryptographic hash collisions, so that's nice. But what's wrong with just a straight cryptographic hash at the plain text password? Take a look. Did anyone notice a pattern? Something else, there's something glaring. We solved one problem, but we didn't solve two. The problem that we did solve is we're not storing a plain text password. That's good. But the problem is we know that JL's BVAC and Aurelion, the cryptographic hash of the password is identical. That means, as Magma Bandit says, hello Magma Bandit, that two people have the same hash password. That means two people share the same password. Both of them, both Aurelion and JL's BVAC share the same password. So, if someone knew the hash function, they could churn out a bunch of common password for the username. Well, that brings up another third problem. The second problem is this. Some cryptographic hash functions are already broken. Okay? So what do I mean by that? MD5 is broken. That means there's already been known collisions. Another one, let's do this. Go to SHA-1. You know that MD5, the hash values are pretty short. They're also the same length. The hash value is the same length. Let's go to SHA-1. SHA-1, even if you do that, okay, let's do SHA-1 instead of MD5. Now, the hash value is a little longer, which is good. The longer the hash value, the better it is. You know what? I'm going to do the SHA-1. Oh. Yeah. And we have a latecomer. I think I'm going to add Magma to the list for a very good reason. Good, 1, 2, 3. Shit. Yeah, we already calculated the SHA-1 of good, 1, 2, 3. You can see that the hash values are a little longer now because I'm using a nicer, better hash function, but not by much. CS105 creator. The hash values are the same. You're seeing the pattern already, but still you're seeing two people, in this case Jake and Aurelion, having the same hash value because they use the same password. I'm gonna add magma bow. Is it? Your password is going to be football. I'm going to use Magma Bandit as an example. So here's the problem. The problem is you still have the same exact problem with using MD5. While the hash value of SHA-1 is a little bit bigger than MD5, SHA-1 is also broken, very much like MD5. You're still seeing that Aurelion and JL's BVAC have the same hash value as a password. That means they're using the same password. But also in this case, I just added, Magma Bandit. Magma Bandit is, well, we knew what his plain text password is. But if you're like a lot of people who use really weak passwords, like football, someone, like people in the world have already pre-calculated the SHA-1 value of every single dictionary word. So while you can't per se reverse, an output and to get back the input, you can infer what the input was because someone already pre-calculated all the hash values of all the existing dictionary words. So if you do a really Google search for 2D all the way up to 6DA, if you do a search for this, you can see everywhere it's like SHA-1. You can see the SHA-1 values. Oh, this is terrible. Actually, this sometimes like using Google is nice because it can. Yeah. SHA-1 hash for football. So you can quote unquote infer reverse it, but yeah, that's because people already have taken the checksum of every single dictionary word. And people use dictionary words, unfortunately, for passwords, so it's really easy to go back. So as what Kevin said, if someone knew the hash function, in this case is SHA-1, because of the length, they could churn out a whole bunch of common passwords for each username. Okay? So, the other thing is SHA-1 is broken. MD5 is broken. What does that mean? What it means is that those two cryptographic hash functions have their known collisions. And this was done not too long ago, it was a few years ago. Google did the work. Called Shattered. It's a website. Google broke SHA-1. The industry cryptographic hash function is used for digital signatures and file integrity verification purposes and to protect a whole wide spectrum of digital assets, including credit cards, yada, yada, yada. And so here's the point. It is now practically possible to craft two colliding PDF files and obtain a SHA-1 digital signature on the first PDF file, which can also be abused as a valid signature on the second PDF file. Okay, and they're two differing PDF files. So good doc, bad doc, this shouldn't happen. All right, and so here's the infographic. A collision is when two different documents have the same hash fingerprint, also known as a hash value. This is bad, that's collision. So potentially impacted systems, HTTPS, digital signatures, version control, Git, because Git, for the longest time, Git commits use SHA-1. I think it still uses SHA-1, I'm not mistaken. Backup system. The caveat is it's still very complex. It's still very complex to do. But this was done like over 5 years ago. MD5, it takes like one smartphone or 30 seconds to find a collision. If you're wanting one shattered on SHA-1, it's 1 year, 110 GPUs. SHA-1 brute force, 12 million GPUs or 1 year. So your defense is to go up. Don't use SHA-1 and use like SHA-256 at the very least. Okay? Use collision detection code. All right. So Unfortunately, MD5 and SHA-1 are still around, and they're not going to go away because of legacy systems. Because Linux systems use, like old systems, use MD5. Okay, Git has transitioned, has been transitioning. Really? Really? (2022)? Ah, they're transitioning. Okay. Thank you. Thanks, Nick Rings. Okay. Also, you may be wondering, why is this important? Like, why is cryptographic hash functions like really important? Um, anyone ever download software before? If you ever download software, any good reputable place, when you download software these days, it should also provide you a cryptographic what is called a checksum, which is the same as a cryptographic hash value. So I'll give you an idea. If anyone ever do go to VLC, go download VLC. It's the best platform independent media player. So as you can see here, I'm gonna go download VLC for my Mac OS. I already have it installed, but I'm gonna go download it on my machine. Come on, I'm gonna save it to my desktop. Takes a few seconds. So it also here says your download will start in a few seconds. If not, click here, display the checksum. And you can see SHA-256 checksum is this value. So why the checksum is really important is if you have actually downloaded the right file. If you download the file, it has to be done. The file has to be done. And you calculate the SHA-256 checksum, which I'll show you how you do in a few moments. And if the hash values match up, then you got the right download. Now, if you calculate the checksum of a download and the value does not match that's on the website, then either one of two things. There's either a malicious download or an incomplete download. So I'm going to go and open up my desktop now, terminal, CD desktop, and we have to wait for the damn thing to down. Slow today. And the way you calculate the checksum, the SHA-250, remember, it's looking for SHA-256 checksum of the file is OpenSSL SHA-256 come on, I gotta finish up. There you go, almost there. Nope, 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 nope. Here we go. Done. SHA-256 VLC-3.0.21-ARM64.DMG is this value. 15DD all the way to 8044. Does that match? Do a find, yep, matches. That means we downloaded VLC 3.0.21 from Mac OS correctly. The checksums match. If you're ever using Homebrew, if you're using Homebrew to download stuff, you can take a look under the hood. It actually does the checksum, the integrity check, automatically for you. Yeah. So whenever you download software by way of Homebrew, any good package manager will always check the cryptographic value or the checksum of the download. Yeah. So this is why cryptographic hash functions are really, really, really important, because it's used for checking data integrity, the I and the CIA triad. And yes, cryptographic hash functions are used for storing passwords as well. But still, going back to this example, this is not good because we can still see that JL Spivak and Aurelion use the same password because they both share the same cryptographic hash value. Not good. So what's the right way of doing this? The right way of doing things is, instead of just storing the cryptographic hash value, is to sprinkle a little bit of randomness to each plaintext password, then do the cryptographic hash of that. So what I mean by that is specifically prepend or append some random 1, 2, 3 character token to the password plaintext and do the cryptographic hash of that. So I'm going to create a brand new column called token. Now I'm going to generate a random token for each of these users. Again, think of these tokens for each user as random. And this is random. So it's just in this case, every user is going to get a random 2-character token. You'll see what we're going to do with this. Okay. So you can see now for each and every user, there is a 2-character token, random, 2-character token each. So now what do is the following. What we do now is, let's use SHA-1 despite the fact it is broken. Let's still use SHA-1 despite the fact it's broken. And I'm going to prove a point. I'm going to do the SHA-1 of good 1, 2, 3, but add a B, append a B to the end, and then you encode that. House of Blues, but then we also append a BC, BC. And then take that, get the hash of that. Money is the most important thing in the world. CC. Good 1, 2, 3, but we append A1 as a token. Flower Pots 1939, BB. Oop. Yeah. CS105 creator, case sensitive at DD. Life is about people, plus FU, irony. Alright, we do baseball in 89. Now remember, we did a search for the cryptographic hash value of the SHA-1 of straight football, or whatever, baseball, whatever it was, and we got something back. But now let's do a search for this cryptographic hash value and using Google and see what happens. Shouldn't get anything. Unless they did a rainbow table or something. No values. Okay, that's not bad. Not bad. Didn't get anything. So now, here we go. And this is the way that is done in the real world. Now we notice, you take a look at the passwords, the password column. No plain text. And also, you can't tell if Aurelion and JL Spivak are using the same password. You can't. There's no way to know now that Aurelion and JL Spivak actually has the same password. That thanks to this idea better known as a token. Does it support? That's a great question. Does it support special characters or just numbers and letters? Numbers and letters. Generally speaking, the token is number and letters only. No special character BS. Great question. Now, this is the way how modern systems store usernames and passwords correctly. Is a cryptographic hash function on the plain text plus some token. Now, this token here, there's a more formal term. The more formal term is not token, but it's a salt. A password salt. Okay? And so what's the whole point of a password salt? And a password salt, there's a great Stack Overflow post on this one. Here it is. So can someone help me understand how salting works? And usually it's just, again, oh, I didn't send shatter, did I? Oh, that worked. I don't know what the hell this is. Oh, link sharing is messed up on Twitch. Okay, so here's what salting is. Salt is combined with the password before hashing. The password and salt are clear values. The salt and clear values are concatenated and the resulting string is hashed. Just what we just did. This guarantees that even if two people were to have the same password, you have different resulting hashes. Also makes attacks known as dictionary attacks using rainbow tables much more difficult. The hash is then salted in the original/clear format along with the hash result. Then, so you may be wondering, how do you actually verify a password? When you want to verify the password, you would do the original process all over again. Combine the salt from the record with the password the user input provided, hash the result, compare it with the hash. Okay? The salt must be randomly generated each and every time. And here it is. All right. So, that being said, now you know about cryptographic hash function, you know about password salts. So how about Linux systems? How do they work? Well, okay, let's do it out. Let's do one out. I'm going to go in to a Linux system that I have at home. And I am going to create some user accounts here. The only user account that I have on the system is me, DEFCON. But I am going to create a few username and passwords on the system. I'm going to pick Nick Rings. And I'm going to use JL Spivak. I'm going to use Kevin Coveney. I'm going to make you. And I'm going to use Tulsi House. I'm just writing some stuff down. And you are gonna be a Tufts house, yes. Yep. Alright, let's create some users. I don't think I need this anymore. I don't need that anymore. Sudo add user. I'm gonna do Nick Rings. Alright, Nick, you still there? I'm gonna give you a password. Oh, my password. I didn't enter it. Sorry. Alright. Alright, Nick Rings. Your password is gonna be. What do you think Nick Rings' password is? Okay. Oh shit, it's SL. Whoops, sorry. Oh, I typed in Jake's one wrong. Oh shit. Okay, sorry. Kevin, your password is gonna be. Anyone want to take a guess what Kevin's password is? And we're gonna add Tufts House. Alright, so I created 4 users. Alright, so we have Nick Rings, JL Spivak, Kevin Coveney, and Tufts House. We created 4 new users on this system. Sorry, Jake. I mistyped the first letter of your username. You know what? I kind of feel bad. I did. So I'm going to say sudo del user, delete all files. What? Oh, remove all files. We'll do it all over again. Should be a take for you a second. All right. Now we got, okay, so we got Jake, Kevin, Nick Rings, and Tufts House. 4 users. What do you think we're going to do now? So we're going to understand 2 things next. Where the usernames and passwords stored on a Linux-based system, and how we're going to crack them. Okay? So, what we're going to do is the following. Let's take a look at where the usernames and passwords are stored. On a standard Unix system, or Linux system, the username and passwords are stored in a file called, in the /etc folder, it's a file called passwd. There you go. Now, as you can see, actually, I'll do a cat /etc/passwd. Let me clear the screen. /etc/passwd file. Here's a list of all the usernames and passwords. As you can see, you see Nick Rings, you see Kevin, you see Tufts House, and you see JL Spivak. There you go. These are all the user accounts on the system. Whoa, 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 really? Yeah, these are all the usernames, and these are all the users on the system. Not bad. Wait a minute. Whoa, 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 whoa. You may be wondering, okay, where's the password hash? Ah. You see, back in the ye good old days, 20-something years ago, they put everything in one file, /etc/PASSWD. The username, the password hash, and all this information. Later on, what they did was they separated out the password hash into a different file. So right now, you have /etc/PASSWD. This file is still extremely important to do like user checking, permissions and stuff, but now the password hash is in a different file. You notice that the password hash is now replaced on each and every user account, Nick Rings, Kevin Coveney, Tulsi House, and JL Spivak with a little lowercase x. So where is the password hash stored? And the answer is in a file called /etc/shadow. Oh, it's a permission denied. And this is exactly the right behavior. You need to be root or temporary root to look at the content of /etc/shadow. So you need to do /sudo cat /etc/shadow. Now you see the password hash. So now you see Nick Rings, Kevin, me, DEFCON, Nick Rings, Kevin Coveney, Tulsi House, and JL Spivak. Okay, interesting. And here's the password hash. But notice that Nick Rings, Kevin Coveney, Tulsi House, and JL Spivak start with two files you need. The other one is /etc/shadow. So, but you have to do it with sudo. You have to do it with sudo. You need root permission to take a look at the shadow file. So you notice something is that you notice the passwords of Nick Rings, Kevin Coveney, Tulsi House, and JL Spivak all start with a $Y$. Okay, well, how the hell you read this thing? Let me introduce to you to how you read the shadow file, everyone. This shadow file, the good read. Alright, so here it is. Linux provide many security mechanisms. One of the most basic is the /etc/shadow file, which holds the hash passwords of users in /etc/PASSWD. Okay, they're going to use encryption and hashing interchangeably in this article, despite the fact that the former is reversible and the latter isn't. Okay, they made it very clear. Nice. So here is how you read a /etc/shadow file. Here's the following format. It goes username, password, change, and a minimum number of days. Okay? So here is the example. So we've seen the username and password. Okay, that's fine. But how do you decipher the hash? How you decipher the hash is this. There are many algorithms for encryption. Now, which one /etc/shadow uses depends on a whole different factors. So if you see essentially the initial characters of the password file, the password field value in /etc/shadow identify the encryption algorithms. If it starts with $1, is MD5. $2A is Blowfish. $5 is SHA-256. $6 is SHA-512. And $Y, lowercase y, is YesCrypt. Okay? So, in all the cases except the DES, the whole format of the field becomes a little more complex. So it's $ID, $ID $, followed by some param, followed by some salt, followed by the encrypted value. So let's take a look at Nick's rings. $, $Y, followed by J9, lowercase j, 9 capital T, that's a parameter, and then a $. And then you see this value right here. That's the salt. That's the hash. $Y, yes script. J, lowercase j, 9 capital T, param, followed by a $. Actually, who was it that? It was Nick Rings. Nick Rings are the special characters. The one special character that they'll make an exception to is the period. Cryptographic hash, the salt, sorry, QY, yada yada 50, followed by, oh my god, all the way up to the semicolon, the hash. $Y, lowercase j, 9 capital T, the param, salt, all the way up to the $, and then everything after the final $, all the way to the colon, the colon is the hash value. Okay? The encrypted value. All right. Cool. So let's try to find out what the password for Nick Rings, Kevin Coveney, Toshi House, and JL Spivak are. In order to do that, we gotta make a copy of both the etc/PASSWD and the /etc/shadow file. So I'm going to do sudo copy /etc/PASSWD, and I'm going to, wait, before I do that, where am I? I'm at my home directory. And I'm going to make a copy of the shadow file too. /copy /etc/shadow. Shadow. Copy. And so here it is. I have two files. Password.copy, and shadow-copy. They're both owned by root still. So I also want to change owner, sorry. So now I can do /etc/password. And a shadow file. We have the two important files that we need for password cracking. Alright. So now what I am going to do is I'm going to fire up another terminal. And I'm going to SSH into my Kali Linux box. Why Kali Linux? Because I have my cracking tools here. I also have it on my Mac. And now what I want to do is I'm just going to go to my desktop. Got nothing on my desktop. So I'm going to do a secure copy. Oh, God. Okay. So I don't have a... Alright, that's fine. So I'm going to have to do something. I got to bring up another tab. I'm going to go to my desktop. So I'm going to make a copy of... Oh, wait a minute. Oh, my bad. Yeah, I did that. So I have on my Mac desktop now, I have the two files. Yes. There you go. But now I want to send over, don't need to worry about this. Alright, now I don't need this anymore. I'll come back to this. Now I have in my Kali Linux machine, both the password and shadow files from this playground box. I don't need this anymore. Close that out. And so the next step is, let's do some password cracking. And the password cracker we're going to use, I want to introduce you, called John the Ripper. John the Ripper is a password cracker. Free, it's open source, and it's also platform independent. So originally John the Ripper was developed, on for Unix to audit frequently used and weak passwords. So John the Ripper, a password cracker, has been used by system administrators and administrators for decades. Okay? So like any tool in cybersecurity, it can be used for good and bad. Here's the John the Ripper website. There's one for Linux, one for Mac OS. Should be a Windows one here somewhere. Yep. They have hash suite. Very, very legendary tool. So here on Kali Linux, it's a good way for me to introduce to you how it works. So to man John. John, a tool to find weak passwords of your users. Using John the Ripper to crack password is really simple. It's just John and then a crack me file. But before you run John, you need a way to combine, both the PASSWD and shadow files. John the Ripper comes with a tool called Unshadow. Unshadow combines both the PASSWD and shadow files. Using Unshadow is simple. Just Unshadow space password file space the shadow file. And so what you do is Unshadow PASSWD copy and shadow copy. And now you get a combination of both files. However, Unshadow also spits everything out to a terminal screen. What you have to do is you have to pipe out to a file, and we'll call this crackme.txt. Okay? Now what we're going to do is we're going to modify crackme.txt and just delete all this stuff. We are only caring about cracking Nick Rings, Kevin Coveney's, Towsy House, and JL Spivas passwords. 4 accounts only. So if I do more, crackme.txt, there you go. Crackme.txt have 4 accounts. 4 accounts that use the same hash algorithm for password, YesCrypt. Now it is time to use John the Ripper on crackme.txt. So you do John crackme.txt. Now, YesCrypt is relatively new, so I'm going to refer to this file called password cracking. This is very new. Now, for years, how do you know what's extraneous? Yeah. How do I know that's extraneous? The one that's extraneous is the one that don't have a password hash. Easy said. The one that is, like if you take a look, more PASSWD copy. Like anyone, actually, let me do this again. Let me do the unshadow again. Any one of these accounts, like this one, I don't want to crack root, because that's me. Nah, okay, no password hash, no password hash, no password hash, no password hash. These are typical Linux and system users for apps, for applications and processes. We can crack for DEF CON if we want. I don't care. Too late. So that's how. Yeah, no shy looking stuff exactly. Now, run John, crackme.txt. Now, because these are all yes crypt, it's relatively new. July of 2021 is here to do -- format equals crypt, which is internal to Linux here. Okay, this won't work on. I don't think this works on Mac OS, but then again, I'm not going to give you yes script to crack for Mac OS anyway. Hit the enter key. Are we ready? So we have 4 accounts. Let's take a look at what Nick's, Jake, Kevin, and Toasty House's passwords are. Here we go. Loaded 4 password hashes with 4 different salts. Just let it run. Just let it run. It's going to use, oh no! So by default, shit. Okay, so Kevin Coveney's password is ABC123. Toasty House's password is 123456. JL Spivak's password, oh, they got Nick rings. And I got Nick rings. Oh boy. Yep, but those are really easy passwords though. Really easy passwords. So as you can see, we cracked all 4 accounts. Kevin Coveney's, Toasty House's, JL Spivak, and Nick Ring's password just like that. It only took, what, 31 seconds to crack 4 accounts. Now, how John the Ripper works is this. Initially, if you don't provide any options, flags other than format, John the Ripper, the first thing it will do, it will crack password using its own built-in word list. Yes, John the Ripper has a built-in word list for cracking, but it's a very small list. So here, I'm going to be proceeding with word list /user/share/John. So I'm going to take a look at that list. And here is John the Ripper's default password list. So if your password is any of these, it's just going to get cracked right away. And these, unfortunately, are some of the most common passwords still used in the world today. How many, what's the word count on this? How many lines are in this file? 3,550. That's not a lot. That's not a lot of words in the word list. Not a lot of words. Okay? So, but the proper way to do this is this. Now, unfortunately, we already cracked all the passwords. No more password hashes go. We already cracked all 4. We cracked Nick, we cracked Jake's, we cracked Kevin, we cracked Toasty House's. All done. Now, this is a rare example. This is extremely rare. However, the important principle is this. How John the Ripper works by default is it's going to start with its own, start cracking password given its own word list pair. But this is a very small word list. So here, I'm going to go back to Mac OS. You know what I want to do now? I don't want, I don't need this, all of any of this stuff anymore. So you may be wondering, can you do password cracking on Mac OS using John the Ripper? And the answer, yes you can. What you do need to do is first of all install John the Ripper using Mac OS. The way you install John the Ripper is using homebrew. Brew install John-Jumbo. Yes, it has to be a very specific version. John-Jumbo is John the Ripper, but really tailored for Mac OS and other like modern systems. So John Jumbo is the way. So brew info John-Jumbo. It is John. So this is like the really like good version, the enhanced version of John the Ripper. Okay. This is an enhanced version. So brew install John Jumbo. Now the one thing is, let's go to CS116, and now you have the password cracking competition. The password cracking competition for this course is an annual thing that we do each and every semester. You have 16 hashes. You see a $1 and a $6. Crack as many passwords as you can. If you crack all 16, you get an automatic A in the course. That's never happened. It's not going to happen. Now, here's how you do the password cracking competition. You're given this entire CrackMe file. I already did the unshadowing for you. You don't need to do it. All you need to do is to run John using wordless. Now, what you don't want to do is crack everything at one time. You want to separate out by algorithm. So I want to show you, and I have an archive of old password cracking competition files. So I'll just do last springs. Go to labs, and you can see go to the packet cracking archive. Yeah, I'll send you the link here. Password cracking archives. Let's go CrackMe Spring 2025. That's this one. So I'm going to download this raw file. I'm going to save this as CrackMe on my desktop. Okay. So I'm going to do more CrackMe Spring 2025.txt. There you go. So what I want to do is I want to copy CrackMe Spring 2025. I'm going to create two different files with it. CrackMe md5.txt, and I also want to do a SHA-512 as well because they're two different hashes. Vim CrackMe md5.txt. So I'm going to remove all the $6 from this one. So now I am going to go back and do Vim SHA-512. And this time I'm just going to delete all the $1s. So more CrackMe SHA-512.txt. You can see all $6 passwords. CrackMe-MD5, all the $1 MD5 password. Okay. Now I have John the Ripper installed here. What do? All you need to do is John, you go to CrackMe md5.txt. See what happens. And I already got one password. We got Sister Bear, Panda Bear. And then after so long, so we already got two passwords from the password cracking competition, just like that. and it uses the default John the Ripper word list. Now, the secret of doing password cracking is to use word list. So I'm going to hit Control C here. When you Control C out of a password crack, it will save the location. So it won't crack passwords that have been cracked already, which is really good. But really, when you do password cracking, you gotta have your computer up and running for a while. Yes, I repeat, when you're doing password cracking, you're gonna need to run computers up for a while. Right now, we cracked 2 out of the 8 passwords in crackme-md5. Crack again. It's still going to go through the word list. Now, ideally, you want to be using your own word list or other people's word lists that you find on the internet. And one of the best resources for word lists is on GitHub. I want to introduce you to Daniel Meisler's SecList project. SecList. It's a security tester's companion. This is a collection of word lists used for security assessments used in one place. Things include username, password, URL, sensitive data pattern, fuzzing, payload, list goes on. Okay, don't worry about these warnings, who cares? Daniel Meisler's SecList. So you can go to passwords. You can see these are all password lists. Dark code is one of my favorites. It's too big. That's okay. Go to passwords. Go to most popular letter passes. Seasons. Not bad. Clarkson University. Oh, look at that. Yeah, all the common passwords in man and known to man are already, well, known to man. All the common passwords, there's so many different subfolders now too. They organize us. So here's how you use word lists in John the Ripper. I'm going to hit Control C. So I will go to my desktop. No, go to my documents folder. I have a copy of SecList. It's big. Go to passwords. And yeah, and I have a file called dark code here. This is one of my favorite lists. How many lines are there with dark code? 1,471,056. So if I do more darkcode.txt, yeah, these were all passwords in the past. It's a big, long list, everyone. In the past, I've known people, they combined all the word lists into one mother of all word lists and use that for password cracking. You can do that as well if you want, sure. So if I am here, I am /users/chow, that's my, and we're going to use dark code. So I'm going to go back to my desktop. So I'm going to go John. I'm going to now show you ls. Now I'm going to do John -- word list. So now, instead of just doing a straight regular John the Ripper crack with this default word list and then brute force, now this is going to crack crackme-md5.txt with darkcode.txt from SecList. Oh, the little things things matter. It's crack me md5.txt. There you go. And just let it run. Don't worry about the warnings. Remaining 6 password hashes, 6 different salts, and just let it run. Then we're just going to let it run. That's all it does. Just let it run, go out for coffee, get lunch, get food, and then come back like a while later. You can use the cloud if you want. You can use other people's, computer, also known as a cloud, to do this. Like other servers that you can find. You can't use homework.cs.tufts.edu. You will actually get yelled at for that, and people will get really pissed. And the one final message I have for each and every one of you is this. Remember, it's only a matter of time that your password will be cracked. Take a look at this table, the number of characters, and then the different cases. Numbers only, lowercase letters only, uppercase and lowercase letters, uppercase, lowercase, and numbers, and then special characters. As you can see, length matters. The character set matters. Oh, we found grizzly bear is this one right here. There you go. It doesn't matter if it's instantaneous, 1 second, 1 minute, 1 hour, 1 day, 1 month, 1 year, 1 century, 1 eternity, 1 billion years. It doesn't matter. All passwords will be cracked given a matter of time. So, password is just a matter of time any password, it's just a matter of time when they will be cracked. When it will be cracked. Your only defense is to use two-factor authentication. That's why two-factor authentication is enforced, required at institutions like at Tufts. It doesn't help that the general public like to use passwords such as hello, password, welcome, all that, like all the dictionary words, Because those, if you're an attacker, number one gateway into systems, weak passwords. There was a company in, I think, the UK that was taken down because of just a weak password, a single weak password. The NSA hunt for weak passwords on systems, system administrator passwords. It's the best way to get, it's the most effective way to gain access into system. You won't believe people just still use weak password. They don't invest in password managers, and they don't use forget about two-factor authentication. Okay. So your best investment, the best thing that you can do, every password is going to be cracked. Use a password manager along with two-factor authentication for your accounts. And that's password cracking. And that is the start of October National Cybersecurity Awareness Month. Take care, folks. Yes. Yeah. Do we got anyone else? T-Mux, yeah. I have never gotten into T-Mux before. Hey, by the way, guys, I'm not going to end on quick this. I'm going to do a session on Git tomorrow afternoon on using revision control in Git. Why? Just because I want to. Yeah, 1:30 tomorrow. I'm going to do a beginner tutorial on Git and revision control. I haven't done one for like forever. But apparently a shit ton of people at Tufts don't even know how to use Git or revision control. Oh, shit, we got Jack Bear. Look at that. We got Jack Bear. Yeah, just keep on going. Yeah, and this is, again, using dark code. Yep, password cracking competition is now up. And I'll be on Git tomorrow. Might as well. All right, I'm going to stop the stream. I'll be back tomorrow. All right, take care, everyone.